This video is going to be the video in which we make the main method called check collisions, which will be used to check the ball's position against the paddle's position and all of the different bricks that eventually we're going to have the ball kind of bouncing around. So this method will return a Boolean. It'll say yes, there was a collision, or no, there was not a collision. It's going to be called check collisions, and it's going to accept a rectangle R that represents the bounding box of either the brick or the paddle that we're checking to see if the ball has collided with. Alright, so first things first, I'm going to write Boolean collision detected equals false, and then we're going to return the value of collision detected. So that just satisfies the idea of the method. So it just make sure that we're returning something. Now throughout the method we are going to determine whether or not we have in fact detected a collision, and so if we have detected a collision, we'll change the value of this to true. Okay, so the first thing that we're going to do is to look into the future. So we're going to say the x destination, the place where the ball is headed, equals x plus dx. Oh, and I called this x destination. Okay, x destination equals the current x position plus the velocity in the x direction. So it looks forward in time, one frame of animation. We're going to do that with the y position also. The y destination, the future position of the ball, is the current y position plus the speed in the y direction. So that's just calculating what the next frame will be in the y direction. We're going to set the value of x temp to x and y temp to y. And apparently I called these things something else also, with capital T's. Okay, capital T x temp and capital T x, or y temp. So these are just like storage containers that make sure the current position of our ball is kept safe, and we can still kind of make choices based on the position without forgetting where we currently are. Alright, so now we're going to do the actual detection of the collisions. We're going to check first whether or not the ball has collided in the horizontal direction, so in the x direction, horizontal collisions. To do that, we are going to calculate the corners of the future ball. We're going to look one frame out in the x direction only, because if you remember the collisions, we want to know if it's colliding in the direction, like in the x direction or the y direction, because we're going to make choices based on which of those velocities has caused the collision. So we need to separate out all the information so that we can make correct choices. So for the horizontal collisions, we're going to calculate the corners based on the destination in the x direction, x destination, but the current y position. And we're going to send it the rectangle R that we're given. So we're going to, whatever this is, if this is a brick or if this is the paddle, we're going to say, okay, please tell me if looking in the future only in the x direction and the current y position, if our ball has intersected with this rectangle in the x direction. So now we're going to say if we're headed to the right, so if the ball is traveling to the right, if we're going right, then if the top right or the bottom right sides of our ball have collided, then we want to make the ball head in the opposite direction. We want to flip the value of dx, of the speed. So, and then we're going to set the value of collision detected equals true. And we're going to place the ball just slightly off to the side so that we don't generate too many collisions. So the x temp is going to equal the integer value of the rectangle wherever the thing is that we're colliding with. And rectangles have these handy methods called getMinX, minus the ball size, I'll explain this when I'm done, divided by 2 minus 1. So this just say, oh, I have to use the parentheses. This says, okay, if we're going to the right, so if the ball is traveling this way, and if it is collided with whatever this is, the rectangle here, so if it's going this way and it hits something, send it back the other direction, that's this line, so flip its speed so that it starts going left, indicate that we have found a collision, and just in case we don't want the ball to continue overlapping with the rectangle, we just want to set the position of the ball to the left side of the rectangle minus the radius of the ball minus 1, just to set it off to the side to make sure that it's no longer overlapping with the rectangle. Okay, now we're going to do that for going left. So if we're headed left, if the ball is traveling left, if we're headed left, then we need to say if, so if we're headed left, if dx is less than 0, if the velocity is negative, then if we have found a collision on the left side of the ball, if top left or bottom left corner of the ball has overlapped with this rectangle, then we need to do kind of the same thing we did up there. We're going to flip the value of dx, so we're going to send it to the right. We're going to say, yep, we found a collision. And we're going to set the position of the ball to just slightly off to the side of the rectangle. So we're going to get the maximum value, the right side, get max x. Oops, get max x, sorry, get max x. And then we're going to say plus the radius of the ball, so the size divided by 2, plus 1. And that way we'll just scooch it off to the side, oops, equals. So the x position that we're going to decide to to choose, so the place we're going to put the ball is represented by this temporary position. And if we've detected a collision when we're going to the left, we want to set the ball to just slightly off to the right of the rectangle so that it's no longer kind of overlapping with the rectangle. Okay, so that is the horizontal collisions. So this is half of the method. Next, we're going to do the vertical collisions to test whether or not the ball has collided while it's going up or down. But I think we should do that in the next video.